In this video, I'm going to briefly show a few things I've done in my development environment to make my life a little bit easier when it comes to building my ROM images for my 286, and also show an update to my Arduino debugger. One of the things that I have to do, of course, is come in, and what you see on the screen here is Visual Studio, and I'm just using this as basically a fancy text editor. And in here I have my lcd.asm. This was a previous source code file that I walked through when I was doing the PPI work. So connecting from my processor to the PPI to the 1602 LCD. And the code here I'm not worried about. It's just an example file that I'm pulling up. Well, when I go build this, I'm using NASM, and NASM is going to create a single file. And that file might look something like this. So here is a single file that is basically a 0.5 megabyte of content. And a challenge that I have, of course, is I've got to now take this content and split it in half, so I have my upper and my lower ROMs. And so that's one challenge I've got to make sure I address all the time. Another one is when I use NASM, I create a listing file, and a listing file looks like this. And it shows my code, and then it shows at what address the different code is at and what actually is in the ROM at that address. So at address 0, I've got an FA. At 1, I've got a B80000, and that's my 3 bytes that got me up to 4, 2 more bytes, etc. So I can go all the way down and see what is in my ROM. And one thing about this listing file, though, is it always starts at 0. And in my case, my ROM addresses start at 80000. So that was one thing I also wanted to somehow adjust, and I cannot find a way to do that with NASM or with any of the assembly directives, the org or the virtual addressing. I couldn't find a way to make this just show me the actual address based on where it's going to be placed in my ROM. And I don't think that's the intention of NASM to do that. So that's fine, but I wanted a way to address that. I also want to streamline this and make this all really easy so that as I'm coding, I can just kind of automate all of that. So I wrote a little batch file, and this batch file is pretty simple. It calls, first of all, NASM, and then I'm going to go ahead and use a binary format, and I'm going to take a parameter that is, well, what file do you want to assemble? And I'm going to output it to that same file name .bin instead of let's say ASM. Plus, I'm going to create a listing file of the same file name instead of .asm, .lst. Then I'm going to call a utility called SplitRom, and I'm going to point to the bin file that was just assembled, and that's going to split it into 2 separate files for me, the upper and the lower byte ROM files. And then I'm going to call another utility called FormatListFile, and that's going to take the list file that was created with NASM and generate a new one, but offset everything for addressing in the listing on the far left, the address column, by whatever value I specify here. And so in this case, I'm specifying my ROM starts at 80000, so I'd like that listing file to offset accordingly, just to make it easier for me to track it. So I can now come down here to my little PowerShell window, my terminal window in Visual Studio, and just run that command of build. And I'm going to build, and I'm going to point to this lcd.asm, which is this code file. And I'm going to close these others, so it's just this file. But when I run this down below, it basically goes through. It runs NASM, and you can see it substituted that variable %1 with the actual name. So I said lcd.asm is what I wanted to build, and output to the bin, and also create the listing file of .lst. Then it automatically called, based on that batch file I wrote, a split ROM, so it split it into an MSB and an LSB.bin. So it took the 0.5 meg file and cut it into 2 1/4 meg files. And then once it was done splitting the file, it generated a new listing file. And that listing file, it took this lcd.lst, offset everything by 80,000, or in other words, 0.5 meg in addressing, and created an adjusted version. So the output of all of that is I've got my bin file, the full 0.5 meg. I then have an LSB version and an MSB version, and those are alternating, so the low bytes or the high bytes. It created the list file, and if I look at that, that's all starting at 0. But then it also created a list, basically an LCD. Let's see if I've got it over here to the right. I don't see it there, but let me open a command prompt to that or a folder location. But in this location, then it created the adjusted version. And so if I open up that adjusted version, this is what it looks like. And you'll see that now everything starts at where my ROM address would be. This isn't actually what's in the assembled code. This is just what's in this listing file. So now I can very quickly know that this is the physical address that this move is going to be at, this B061. And I don't have to do that mental math of adding 80,000 to everything that I'm doing. So that's really handy. And so I just thought I'd show that kind of a neat little setup that I think I've got going there that makes my life pretty easy. It just allows me to go in, create the code, jump down here, tell it to build, and then everything's ready to go. My ROMs are ready to go, and this listing file that I find more usable is available. So then the next step is a little program I wrote. This is a Windows user interface that sits on top of my Arduino debugger. And so right now I have my system turned on, the 286 breadboard system. I have it on manual clock, so it's just sitting here not doing anything at the moment. But I'm going to go ahead and connect, and actually I'm already connected. So when I first come in here, it looks like this. I can pick my Arduino, I can connect to it, and it now shows I'm connected to COM7 at 921, roughly 920 kilobits per second. And once I turn on my clock, I take it out of manual into auto mode, for example, it's going to start outputting all of that Arduino logging that you previously saw in previous videos where I was logging it to a terminal window. It's going to log it to this top window. But I can also, in addition to that, select that listing file that I just created. So I'm going to go grab that LCD adjusted list file, and that loads it down below. Okay, that's great. But now here's kind of the nice part. I'm going to go ahead and flip on my clock onto auto mode, so it's actually going to start running. And I'm going to do a reset on it. So I'm going to hold down the reset for a few pulses and let up. And then we should start seeing that it will go through its reset sequence here shortly. So it's got 50 there. Okay, there we started running through this. So it's doing its initialization, and now it's actually running through the code. And I'm trying to do my best in the upper window to figure out what is it doing. But notice down below, it automatically now tracks within the listing file, where is it really at? So this is reading the physical signals from the processor and dynamically moving my listing file around and highlighting where is my processor at? What is it processing right now? So now I can be really lazy. I can just let this run, and I can just look at the screen and see, oh, right now it's working on a push A. Okay, now it just jumped up to 800071 or 80071. It's doing a push. It's moving its way down through these whatever commands that you see there. So pretty cool. I kind of like that, and like I said, now it lets me with a little bit less effort do debugging as my system is running. Now the speed you can see at which I'm running right now, I don't know how fast this will go. It's obviously not going to go real fast enough for me to debug, but I'm going to try to turn it up a little bit here, and we'll just see at what point does it really stop wanting to keep up. So far that's going pretty well. I'm going to max out my 555 timer. So this is the fastest my 555 will go, and you can see it's running through that just fine. So right now it's working to print out stuff to my LCD screen, and up above I can see what it's doing. Down below it's just keeping up and showing me where it's at in the code. So kind of cool. Thought I'd share that. And upcoming, I am hopefully going to have an update showing some interrupt work, but we'll see where that goes.